Hello, it's Mr. Troja. We're doing some astronomy notes. This is the Sun Structure Part 2 in a two-part series. So we ended on this. Want to talk about the other activity on the outer edges of the sun. We had talked about the corona and the chromosphere and the photosphere in the last video. So we're going to talk about prominences, which are large loops of ionized gas, and then flares, which are very, very violent. There's a video that you should have seen that talked about coronal mass ejections, and so that was caused by a flare. So prominences, like I said, they're big loops of hot plasma. They're caused by magnetic field, or they follow magnetic field lines, and they originate in a chromosphere. They can be very large. One was seen to be nearly the size of the sun itself. Here's a picture of the photosphere with a prominence. As you can see, it's being shot out from the main sphere of the sun. This is another one. I thought it was cool. It looked like a crazy devil rising out of the surface, so I thought it was a fun one. So here's some animations of solar flares. As you see, it's plasma that's just being shot out, and not only visibly we can see that, but it also is shooting all kinds of other particles and sending them flying towards Earth or whichever direction it was being shot out from. When we have one of these flares, they actually have, this is a photo of a shock wave going out from where the flare was erupted from. We talked about these magnetic structures, but it's pretty hard to see. Now this is a picture taken by satellite in ultraviolet, and so you can see, we've talked about these. Here's these loops that are coming off, which is pretty cool. I want to talk about filaments. A filament is a prominence. We saw that picture of the prominence that's coming out from the surface, but a filament would be a prominence that's coming out from the surface is just we're looking straight at it, so we're only seeing it from almost from above. It's like my hand here. You can see my hand like this, but if you were to look at it this way, it looks totally different. There you go. So that's essentially what a filament is. Here's an old drawing that shows all the things we've talked about. We have our chromosphere and a prominence, which is the plasma that's coming off of that. A much larger one, the flare. We've talked about a filament here being just like a prominence, but seeing it from a different angle. Talked about sunspots in the last video. Granules are all these little parts here, the photosphere, and spicules are little jets of flame coming out. So let's talk about solar wind for a second. Solar wind is these high energy particles are being released, and they will travel to Earth and sometimes cause some interference with our communications. They are particles coming off the corona, and they're being thrown away with a velocity. If down here at the bottom of the slide, it talks about how fast. So light travels 300,000 kilometers a second. So light can reach us from the sun in 8 minutes. But the solar particles do not travel as fast. It takes them a few days. They're only going 500 kilometers per second. Anything that has some kind of mass like electrons and protons is not going to travel anywhere close to the speed of light. So the sun continues to lose these particles all the time, and we think about what hits the Earth, but the sun is a sphere and it's going out from all directions at all the time. Solar wind does interact with objects. It runs into the Earth, and that's what causes the aurora borealis. Is what we probably have heard more here. It produces the tails of comets. As the comets get closer, it starts to melt off of the nucleus, and then we get these tails. and the directions of them are based on the solar wind, and the heliopause, which we've talked about on the edges of the solar system. So here's this solar wind coming off, and it bends around the Earth. The Earth has its own magnetic field, and so the magnetosphere of the Earth here is able to deflect a lot of that, but it doesn't always deflect all of it. So that's how we get some of these colors. The auroras are caused by this disturbance in the magnetosphere by the solar winds. So here's a pretty cool image of that aurora happening around Australia. It was pretty awesome. All right, so that ends part 2 of the sun structure. We've been talking about the exterior or the outer layers of the sun. Now, in the next video, we'll be talking about solar fusion and the interior layers of the sun.